Hello, good morning viewers. Here is an interesting factorial equation that involves permutation. We are asked to find the value of n given that n permutation 4 is equal to n plus 1 permutation 3. First of all, let us define what this permutation means here. If you are given n permutation r, it is the same thing as n factorial divided by n minus r factorial. For the domain, from the left-hand side, you know that n is greater than 4. And from the left-hand side, n plus 1 is greater than 3, which implies that n is greater than 2. Okay, let's begin with the solution. For n permutation 4, it can be written as n factorial divided by n minus 4 factorial. And this is equal to the right hand side, we have n plus 1 factorial divided by n plus 1 minus 3, which is the same thing as n minus 2 factorial. Okay, now we can cross multiply. If you cross multiply, you have n factorial multiplied by n minus 2 factorial, and this is equal to the other one, which is n minus 4 factorial multiplied by n plus 1 factorial. You should know that n plus 1 factorial can be written in terms of n factorial when expanded. Likewise, n minus 2 factorial can be written in terms of n minus 4 factorial when also expanded. So to the left hand side, I still have n factorial, and I want to expand n minus 2 factorial, which is the same thing as n minus 2 multiplied by n minus 3 if you subtract 1, multiplied by also n minus 4 if you further subtract 1. We have factorial. I'm going to stop here because I have n minus 4 factorial to the right. So this is equal to n minus 4 factorial. Then I have to also expand this. I have n plus 1 multiplied by n factorial if you subtract 1. N factorial will cancel n factorial. N minus 4 factorial will cancel n minus 4 factorial. What I have left is n minus 2 multiplied by n minus 3 equal to n plus 1. If you expand n minus 2 times n minus 3, you're going to obtain n squared minus 5n plus 6. And to the right, you have n plus 1. Let us bring everything to the left-hand side. This is n squared minus 5n. If n crosses over, it becomes negative. We have minus n plus 6. If 1 crosses over, it becomes negative. And to the right, we have 0. This is n squared minus 5n minus 1 is minus 6n. Then 6 minus 1 is 5. And this is equal to 0. This is a quadratic equation that we can solve by factorization. I have n minus 1 multiplied by n minus 5. That is what is going to give me back my quadratic trinomial, because negative 1 multiplied by negative 5 will give me positive 5, and negative 1 plus negative 5 will give me negative 6. So if you set each of these factors to be 0, the first factor n will be equal to 1, and in the other one n will be equal to 5. But remember, from our main domain, we say that n is greater than 4, likewise greater than 2. Therefore, we are going to consider n equal to 5 as our solution. But let us test it in the main equation to testify whether this is true or not. Let's substitute it here and compare it with the result of n plus 1 permutation 3. For n permutation 4, it is the same thing as 5 permutation 4. And this is equal to 5 factorial divided by 5 minus 4 is the same thing as 1 factorial. This is 5 factorial because 1 factorial is equal to 1. So what is 5 factorial? 5 factorial is the same thing as 5 times 4 times 3 times 2 times 1, and that will give us 120. Then let us test it in n plus 1 permutation 3. N is 5, remember, plus 1 is 6, so we have 6 permutation 3. This is equal to 6 factorial. Divide by 6 minus 3 is 3. We have 3 factorial here. Let me reduce 6 factorial in terms of 3 factorial. This is equal to 6 multiplied by 5 multiplied by 4 multiplied by 3 factorial. Divide by 3 factorial. This 3 factorial will cancel this 3 factorial. 6 times 5 is 30. 30 times 4 is 120. And hence the left hand side is equal to the right hand side. And we conclude by saying that our real solution, n equal to 5. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.